Hello everyone, and welcome back to the Fluctus Channel. Since the conception of aviation, military forces have tried to exploit this technology. Part of this includes naval aviation, which took its first steps during the First World War, but was relevant during the development of World War II. Since then, the Navy and Air Force have developed better technology and better aircraft, influenced by the conflicts that have appeared through the years. The application of military power from aircraft carriers has influenced the development of iconic aircraft such as the V-22 Osprey, with both vertical takeoff and landing and short takeoff and landing capabilities. Or the Tactical Airborne Early Warning E-2 plane.
We're pushing these aircraft hard, and it requires dedicated efforts of everybody to get those aircraft flying up in the air and safely recovered.
Several aircraft have been the ideal tools to be used in naval aviation. Of these, there are a few that stand out, such as the F-18. Since its development by McConnell Douglas and Northrop in the late 1970s, the F-18 was intended to be a multi-role combat aircraft for the United States Navy and Marine Corps, designed as both a fighter and attack aircraft. Introduced in the 1980s, this aircraft has undergone constant improvements, resulting in several models, from the F-18L developed by Northrop to the F-18 Block 3 Super Hornet, this being the latest iteration developed by Boeing. Those modern models can perform virtually every tactical mission thanks to their advanced avionics, consisting of an advanced targeting infrared system and a two-way multi-mode voice and data communication system. Those devices allow the plane to operate as part of a networked force, sharing real-time information with other aircraft. The F-18 can reach speeds up to Mach 1.6 thanks to its two General Electric F414 GE400 engines, capable of generating 17,000 pounds of thrust each. This amount of power is supported by an enhanced airframe, with 42% fewer structural parts than the previous generations of the Hornet. These capabilities are demonstrated during the countless missions in which this aircraft is used. Many of these are launched from enormous aircraft carriers, like the Nimitz class, that can accommodate a maximum of 130 F-18 Hornets or 90 aircraft of different types. Those aircraft form part of the Carrier Air Wing, a naval aviation organization that is composed of several squadrons with fixed-wing and rotary-wing aircraft. This is why the logistics inside the aircraft carrier during a mission are complex, requiring the precision of each crew member. It all starts with the transportation of planes through the ship. Spotting dollies, which are three-wheeled vehicles similar to tractors with hydraulic arms at the front, are used to move the aircraft to the flight deck. Once on the top carrier, the pilots attend the mission briefing, where they receive the important points on the mission, like location and weather conditions. Such preparation is done alongside crew members, so the pilots can coordinate with the deck staff. With all the mission information clear, the pilots proceed to board their aircraft, for which they must perform pre-flight checks. This process includes reviewing the operation of the aircraft's main systems, including avionics, controls, and weapon systems, when necessary. This is done while the plane is towed toward the catapult shuttle, where the carrier crew attaches the system to the nose landing gear. The pilots do the final engine run-ups to ensure the engines produce maximum thrust. Finally, the crew activates the catapult system that accelerates the aircraft to reach the necessary speed to take off. This procedure is followed for every kind of operation, including tactical missions, military exercises, and training sessions, in which the pilots get used to the launching and landing process in an aircraft carrier.
And then once we get the jets all started up and mission ready, the folks here on the ship get us launched off. And just seeing that entire cohesive unit come together to eventually put bombs on target on the first pass is probably the most rewarding part of the job.
These training processes are vital, considering the minimal margin of error that exists on an aircraft carrier. For this, pilots use special aircraft specially built to accustom them to takeoff systems, such as the catapult, and especially to the landing procedures at the aircraft carrier. Planes like the T-45 Goshawk come with all the necessary equipment for the pilot, like the catapult tow bar and the arresting hook. Exercises of this type are carried out during training programs, such as the popular Top Gun, which teaches air combat maneuvering tactics and techniques to selected naval aviators and naval flight officers.
However, we realize that we can't have perfection in everything, but it is the bar for us, which is perfection. We want to make sure that the fleet, both the Navy and the Marine Corps, strives to the same thing.
Another aircraft used during this kind of training exercise is the Beechcraft T-34 Mentor, which has remained in use for more than 7 decades. Its latest model is the T-34C, powered by a Pratt & Whitney Canada PT6A 25 turboprop engine developed in 1973. However, training and practice sessions also occur on the ground during aircraft maintenance, where more experienced members teach newcomers how to follow the correct procedures for repairing or replacing aircraft components.
Making you Facebook famous, everyone.
These preparations that a pilot must go through are necessary to reduce any type of risk that impacts the life of this person and the members around them. This is especially critical in environments such as aircraft carriers, with many risky items packed into a small space. One of those risks includes foreign object debris on the flight deck that might hamper the takeoff and landing procedures, or cause an accident. These incidents can occur both aboard these vessels and during in-flight operations. This has been the case with airplanes such as an F-18 that had a failure in one of its engines, falling into the ocean without any casualties, since its pilot used the ejection system during the said incident. For cases like these, where an aircraft falls into the sea, one of the greatest risks for the pilot and crew is entering water into the cabin. This is why survival training is carried out by the pilots, where various emergency cases are explored, including aircraft flooding. Said training consists of using a false cockpit with several pilots inside, which is slowly submerged into a pool for which the pilots must follow the proper procedures to emerge safely from the situation. For these incidents, members of the squads train for search and rescue missions in aquatic environments. Usually, this includes members of the Navy Helicopter Sea Combat Squadron and rescue sailors.
So this training is able to prepare us in the event we had a water landing, we would be able to safely get out of the aircraft.
All of these events drive the development of better systems and devices to improve the conditions of the pilots and the very aircraft they operate. This is done in specialized centers like the South Engineering Facility at Naval Air Station in Patuxent River. This facility, with 40 laboratories, plays an important role in the research, development, and testing of naval aviation systems, enhancing their capabilities and operational readiness. These labs focus on anything that interfaces with human operators, aiming to improve ergonomics, safety, and overall performance. An example includes the Vision Labs, where eye protection solutions are developed, such as laser eye protection and enhancements for night vision goggles. Their altitude simulation labs can replicate the conditions of high altitude to study the human response at such a state and test new devices that can ensure their safety in this environment. Similarly, an environmental stress testing laboratory evaluates human performance at different temperature values and humidity. All those sites are integrated with the Aeromedical Expertise Facility, including practicing clinicians, physicians, vision scientists, research psychologists, and audiologists. Those experts collaborate with engineers to get correct feedback on the new devices and systems that have been developed. This ensures that such technologies are designed with a thorough understanding of their impact on human operators. By understanding and responding to the needs of the fleet, new technology can meet its goals faster and more efficiently. The efforts applied in the development of better concepts have led to the improvement of the safety of pilots and their effectiveness when carrying out their operations. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.